Good morning, one and all. Today, we are going to see about the problems in the Gauss-Seidel method. Already, we have seen one problem in Gauss-Seidel method. Now, we are going to see some problem, a problem in the Gauss-Seidel method. The following is the system data for the power flow solution. Take note this problem. The line admittance are given in the system. So in the previous problem, how they given is they have given the like bus diagram. Here they have given the data and they are asked to formulate the your bus system. Okay, so here the bus code is given and also corresponding admittance are given. So 1 to 2, the admittance is 2 minus J8. Next 1 to 3, admittance is 1 minus 4J. 2 to 3, admittance is 0.666 minus J into 2.664. Next 2 to 4, 1 minus 4J. 3 to 4, 2 minus 8J. And here the schedule of active and reactive powers also given. Schedule of active and reactive powers also given. So in this first bus is given. So here they have given like voltage is given and the phase angle is not given. See here phase angle is not given. So phase angle you need to assume. Okay, and that is the slack bus. So assume means that is 0. Okay, so here P this slack bus, so P and Q not mentioned. And the next bus, second bus is PQ bus. In the PQ bus, what they have given, P and Q values are given. Voltage is not given. So here we have to assume the voltage as a flat start, as I said in the previous class. 1 plus J 0 flat start. Next third bus also PQ bus. P and Q values are mentioned and V values is not given. So we need to assume the voltage and phase angle as 1 plus J into Z. Next, fourth bus also PQ bus. We need to assume P and Q values are given and we need to assume this voltage value as 1 plus J G. So sometimes, as I said before, in the data itself, some insufficiencies will be there. Insufficient means they will not mention the phase angle like. So that time you need to assume that as 0 phase angle. And if the voltage value also sometimes not mentioned, you need to start with a flat start. So that time don't claim the values are not given. So the problem itself wrong. So they will be given full marks. No. Need to assume certain values if they are not given. Okay, so here in this problem it is given and a few values are not given. We need to assume. So flat start we need to assume that you already know, and if the phase angle is not given, you need to assume as 0. That's all. Very simple. So what they asked to do, determine the voltage at the end of the first iteration using Gauss-Seidel method. Take the acceleration factor alpha is equal to 1.6. So this some problem is given. Say for example, the data first you go through fast. Okay, no need of. So first what all the things is given, not given. So that you just take a fast review so that you understand what is given, what is not given, what we need to assume like. So this is the problem they have given. Now we need to solve what they ask. So determine the voltage at the end of the first iteration using 4 bus voltage we need to calculate and 4 bus voltage. So from this I have framed solution. From this I have framed this bus diagram like this. Okay, so here they have given 1 to 2, 1 to 3, 2 to 3, 2 to 4, 3 to 4. So so the connection is there from bus 1 to 2, 1 to 3, 2 to 3, 2 to 4 up to 3 to 4. So with this, I have drawn this connections, this bus diagram and connection. So totally 4 buses are there, and the admittance values also mentioned. So admittance values, what I did is I marked here. I marked here from bus number 1 to 2, that is admittance, then 1 to 3, 2 to 3, 2 to 4, like that. I have marked the admittance here. Next solution. What is the first step? The first step is formulate the Ybus matrix. So you no need of much introduction to this Ybus matrix, because already I have taught you. If you don't know how to formulate the Ybus matrix, go through my previous classes. So here we need to formulate the Ybus matrix. So here 4 buses are there, then 4 cross 4 matrix will come. Okay, 4 cross 4 matrix. So Y11, Y12, Y13, Y14, Y21, Y22, Y23, Y24, Y31, Y32 up to Y44. So here the diagonal elements alone, this Y11, Y22, Y33, Y44, I think you need to calculate. Rest are all are already there. Just you take a minus sign before, and you can easily write the off diagonal elements. So diagonal elements, what Y11, how many? So in first bus, how many elements are joining here? 2 elements are joined. So 1 plus J, 4J plus 2 plus 2 minus 8J. So that you need to add over here. So simply if you add over here, it is coming the answer as 3 minus 12J. So similarly, the second bus, 3 values are there. 2 plus 8J, 0.666 minus J into 2.664J, 1 minus 4J. So don't round off any values. As I said before, clearly, if you round off, the answer might be more variation will come. Automatically, they will reduce the marks. Whatever there given in the problem, blindly you take. After decimal, so even 4 digits also, 5 digits also given in the problem, you take, because you are not going to do any calculation. Your scientific calculator only doing the calculation. So directly you can take those values. So now this bus 2, you have the Y22 you have written. Next, what is Y33? Y33 also 2, 3 admittance values are there. So joining in that third bus. So here you have to add 1 plus 4J plus 0.666J minus 0.666 minus J into 2.664 plus 2 minus 8J. Simply you type in scientific calculator, directly you will get the answer. Next, similarly, Y44 here, 2 minus 8J, 1 minus 4J. So you just add it and easily write this Y4. Just the off diagonal elements, you know. So Y12 means Y12. So here, this value minus of 2 minus 8J. Okay, so minus 2 plus 8J will come. So similarly, minus 2 plus 8J. So similarly, all other values, this, you know, no need of giving much introduction for this. Next to Y12, next to Y13. Y13 is minus of 1 minus 4J. Next, Y13, Y14. Y14 no, Y14 no connection. Y14 no connection, so 0. So like that you need to simply fill this matrix and formulate the Ybus matrix. Okay, this you know. So now this is the answer for this Ybus matrix. So you calculate, you make it as homework and you calculate it. Okay, so this matrix only will come. If not, okay, if you are not getting the same answer, you just put it in the comments. But you may get the same matrix almost, because I also calculated with the scientific calculator only. So I didn't round it off anything. The same after decimal, I have taken all the values. Minimum 4 values. More than that also you take. And here, next, what is the next step? Assume the flat start. And here, V1 not initial value. V1 not value already they have given. V1 not value. What is V1 not value? Already given in the problem as 1.06. Okay, 1.06. Next, what is V2, V2 not, V3 not, V4 not? It is a flat start. It is not given because all are PQ bus. So voltage and phase angle values are not given. So simply you can make the flat start. That is 1 plus J0, 1 plus J0, 1 plus J0. That is the flat start. Okay, so V2 not, V3 not, V4 not. That we assume. Next, coming to the iteration K is equal to 0, P is equal to 2. Okay, bus number we are starting with the 2. Next, Q is equal to 1. Okay, already we have seen why we are taken this the previous problem. Just go through my previous problem also. Just next, VPK plus 1. This is the generalized formula. VPK plus 1 is equal to 1 divided by YPP into PP minus J into QP divided by PP the whole power K star. Star, what is star here? Star is nothing but that phase angle will be in the negative. Say, for example, whatever the values you are taken, say, for example, this VP is 1 plus J0. So if it is star means that phase angle alone you need to mention in the negative value. That is imaginary part. That is the phase angle. So 1 minus J0. 1 minus J0. So here, instead of 0, whatever the value, sometimes there might be some values for this phase angle, some 0.4 or 0.5 like that. So that you need to take minus of 0.4 J like that. So here it is given as 1 plus J0. So as it is, you can take. So minus summation Q is equal to 1 to P minus 1, YPQ, BQ, K plus 1 minus summation Q is equal to P plus 1 up to N, YPQ, then BQ of K. So here you substitute K is equal to 0, P is equal to 2 and Q is equal to 1. Then the this particular formula becomes V2 power 1 is equal to 1 divided by Y22 because P is equal to 2. Next, P2 minus J into Q2. P2 minus J into Q2 divided by V2 naught. V2 naught, the star minus. So here PQ, what is the PQ here? 2, 1. Okay, Y21. Next to Y1 is not. K is not. And minus. So Q is equal to 1 up to P minus 1. So P minus 1 is 2 minus 1. It is 1. So Q is only 1. So sometimes you have to very careful here. Sometimes here for calculating next bus, P is equal to 3 will come, 3 minus 1. So here 2. So you need to carry over 2 times. So first one time, because summation is there now. So this particular term plus again second term Q is equal to 2. So you need to take Q as 2 and the corresponding values has to be noted down. So you need to be very careful while doing this part, that is summation part. So up to what? Up to what? And what is the P? P is 2 here. Sometimes P is equal to 3 here. Sometimes P is equal to 4 here. So correspondingly, you need to summation. Summation means you need to add other terms also here. Okay, so that you need to careful. Next, here summation Q is equal to P plus 1 up to N. So P plus 1 is P is nothing but 2. So 3 to 4. So here you see 3 to 4 means 2 times 3 and 4 fourth value also you have to take. Okay, so minus of here, minus of this value, plus value. So minus minus into plus is minus. So here I have taken as minus. Okay, otherwise you take whole bracket, then you take minus. So whatever is there, it is user defined, your own. So I have taken as minus here, but you take plus here and you put one bracket here. That's all. So here y23, y3 naught minus y24, y4 naught. Like that it is coming. So similarly, you need to substitute. What is y22? Y22 from this matrix. Y22, yeah, 3.666 minus j into 14.664. Like that, you need to substitute whatever the values. What is P2? P2 already given, directly given. So sometimes here directly given in the problem. Sometimes what they will do is they will segregate it into generator bus, load bus like that. So how to calculate the generator bus, load bus? That is the previous problem we did this thing. Okay, so that you just go through the previous problem number 1. So here, what we are doing is here directly P and Q values given. So no need of calculating that. If much is not given, you will be so happy. Why? Because calculation is somewhat easy. If say for example, generator bus is given, load bus is separately given, and that too real power is reactive, but then you need to calculate it again and you need to substitute what is P like. So you see the problem first. Okay. So while seeing the problem itself, you can easily understand whether the problem is easy or it might take more calculation like. Okay. So and no need of going for 2 iteration, stop with 1 iteration, because in exam point of view, okay, if you go for 2 iteration, it will take more approximately 1 hour. If you calculate for, if it is 4 bus system, it will take 1 hour. If you calculate for only 1 iteration, you can simply solve within half an hour or 20 minutes like that. Okay, it depends on your how fast you are doing the calculation. Next, yeah, just simply substitution here. Y23 V3 naught and minus Y24 into V4 naught. Just I am substituting all this values. V3 naught you know, V4 naught you know, Y23 you know, Y24 you know. Just substituting, simplifying. After that simplifying, you will get the answer like this. V2 dash is equal to 0.9855 minus 0.243 J. This is the value for V2 dash. Next, VP accelerated value or VP new value. VP accelerated value, VP accelerated is equal to VPK plus alpha into K minus VPK plus 1 minus VPK. So that is nothing but del VPK, change in the this voltage value. So that you separately calculate, that is your own wish. So here we are calculating it separately. Del VPK is equal to VPK plus 1 minus VPK. So K value, you know, 0. Just substitute it. Del V2 naught is equal to V2 dash. That is, sorry, V2 1. That is not dash. V2 1 minus V2 0. Initial value. V2 0 is initial value. So V2 1 is, so that's just take it from the data. V2 1 is 0.9855 minus 0.243 J minus V2 naught is minus 1. So simply simplify this and you will get the answer as del V2 naught is equal to minus 0.015 minus 0.243 J. Next, V2 accelerated value. Just we have calculated only del change in the voltage, that you need to substitute and you need to calculate the accelerated value or new value. So accelerated value is equal to old value, that is initial value. Initial value is V2 naught. Okay, that is 1 plus J0. So J0 is there. So we didn't take it. Otherwise, you need to take that particular imaginary value also. Plus 1.6. Just substitute it. How 1.6 alpha is 1.6 into this particular answer 0.0145 minus 0.243 J. Okay, simply substitute it and calculate the answer. So V2 dash accelerated is equal to 0.9768 minus 0.3888. Don't round it off here. J. So this is the answer for V2 accelerated value or V2 dash V2 1 new value. Okay, next after the next bus, we are going to calculate for next bus. K is equal to 0, P is equal to 3 and Q is equal to 1. Previously we taken P is equal to 2. Here P is equal to 3. Simply substitution. V3 dash equal to 1 divided by Y33, P3 minus J into Q3 divided by V3 star minus Y31 V1 minus Y32 V2 1 minus Y34 V2 V4 naught, that is initial value, Just this is the generalized equation. Just generalized equation already you know. Why VPK plus 1 is equal to 1 divided by YPP. PP minus J into QP divided by VPK star minus summation Q is equal to 1 up to P minus 1 YPQ PQ K plus 1 minus summation Q is equal to P plus 1 up to N YPQ into BQ K. Okay, just a substitution here that the values K is equal to 0, P is equal to 3, Q is equal to 1. You will get the you reformulate this V3 that like this equation like this. Okay, so just a substitution that already we have seen. Just a substitution Y33 what Y33 from the buzzer Y33 from the bus, then PP minus. So PP means P3 minus J into Q3. So here this 31 B1. Okay, the Y31 B1 that value minus 32 B2 1 minus 34 here V4 not. Just a substitution, you'll get the answer. After calculating, you'll get the answer as V3 dash is equal to minus 0.3244 minus 0.023 J. Just tell in comment whether you are getting the same value for you also, because I have calculated like this. So you also doing with the scientific calculators, then the same value should come. So just to make tell in comment whether you are getting the same answer. Next, del VPK, change in the voltage you need to calculate. This VPK plus 1 minus VPK. Just a substitution, you V3 1 minus V3 not. V3 1 what? Already we calculated. V3 1. Just take over here. Minus VB 1 plus JG. Okay. So if you simplify, you will get the answer as del V naught. Del V naught is equal to this value you are getting. So again, you are substituting in the accelerated value. So V3 accelerated value, V3 1 accelerated is equal to V3 plus alpha into that del Vp. Okay, del Vp already you calculate, just to substitute and simplify it, you will get the answer like this. Minus 1.150 minus 0.036 J. Tell in the comment whether you are getting the same answer or not. V3 1 accelerated is equal to, or otherwise V3 1 u is equal to this answer we are getting. Next, taking the fourth buses, K is equal to 0, P is equal to 4, Q is equal to 2. VPK plus 1 is equal to 1 divided by YPP. This formula, PP minus JQP divided by VPK star minus summation Q is equal to 2 P is equal to P minus 1, that is 3 here. YPQ, PQK plus 1 minus summation Q is equal to P plus 1 up to N, YPQ, VQK. Okay, just to substitute here, you will get the answer here. Like 1 divided by Y44, P4 minus JQ4 divided by V4 naught, the whole power star minus Y42 into V2 1 minus Y43 V3 1. Just to substitute all the values for here from the data already we calculated. Just to substitute, simplify it by using your scientific calculator, you'll get the answer like this. V4 1 is equal to 0.1262 minus 0.074 J. Don't round it off. Next, V4 accelerated value. V4 accelerated value is equal to V4 naught plus alpha into that del Vp. Del Vp you need to calculate. Del Vp directly we are calculating here. Del Vp is nothing but this value, V4 dash minus V4 naught. Okay, so without a formula also you can directly write it. Okay, whatever the V4, say for example V4 if you calculating, here also V4 1 minus V4 dash, that's all. Similarly for all, one say for example first bus if you do with the formula, the second buses and all you can skip, but while skipping the formulas, you should be very careful. If you skip the formula, sometimes if you miss, say for example, if you miss instead of 4-2 and 4-3 also there, if you miss this 4-3, okay, because you are not substituting in the formula simply like blindly you are putting the values here. Sometimes if you miss this, the whole problem will be wrong. So that's why while calculating this VPK plus 1 alone, you just write the formula and substitute the values for that and substitute the corresponding values for that. Okay, like that you takes for calculating this V4 accelerated value, no need of writing the formula and substituting directly you can do because then well versed. First time you use the formula, next time you just directly do this. Next, while simplifying this, you get the answer as 1.20 minus 0.1184. That is new voltage value, new voltage value or accelerated value. V4 1 new or accelerated value is equal to 1.20 minus 0.1184 J. This is how you need to calculate. Okay, so here you see, here you need to identify how many buses are there. How many buses are there? That much voltage you need to calculate, that much accelerated voltage, change in the voltage and accelerated, that is new voltage, you need to calculate. Say, for example, 4 buses are there. So here also 4 buses you need to calculate. V2 dash, because V1, you may have a one question. So why V1 dash and change in the accelerated value for V1 1 is not calculated, because V1 not calculated means already mentioned in the problem, because that bus is a slack bus already mentioned in the problem. No need of calculating that again. Okay, so that's why we are starting from the second bus onwards. So that you need to remember always. You need to start from the second bus. If the first bus is a slack bus, mostly first bus will be slack bus. If not, you just calculate it. That's all. But mostly, almost all problems, so first bus will be the slack bus. So how many buses are there? That much voltage. Okay, voltage you need to calculate, and new voltage also you need to calculate. What is the initial voltage? What is the new voltage? So with this problem, we are calculating what is the initially how much voltage in that bus. Okay, so after injecting the reactive power, real power, what is the accelerated value or new voltage in that particular bus? And almost while calculating that values, almost you need to remember what is the this value, that is accelerated value means what is this value, that you need to it is 1 plus 0j. It is near to always this change in the new voltage value should be near to 1. 1 plus 0j or 1 minus 0j, like that almost it should near to. If not, you're getting some other values here. Say, for example, instead of 0.9768, you're getting 3.1 something plus some values here. Instead of 0 point some values, you are getting 5.4j, like that. Your answer is wrong. So that also you can clearly understood, like your answer is wrong, some calculation mistake is there. It should be nearer to 1 plus 0g or 1 minus 0g. That you need to understand. Okay, so here also you see here also approximately near to 1 plus 0g. This also it is somewhat varying, like 1 plus 344 minus 0 point. So, but it should be near. It should be near. Then the answer is correct. That like that you can verify your answer. Okay, here also you see approximately 1.2 minus 0.11 j approximately. So that you can easily remember, so that your answer also nearby answer